Hi guys, so this is a video for my asynchronous learners. I know there's been a lot of changes with the schedule, so I just want to make sure that I'm providing as much quality as I can when I'm going over topics that I do with my in-person students. So today it's just a quick video going over lesson 50, the questions that you work on for the assignment. Everything is in the notes for you, and the notes have also been uploaded, so hopefully that helps you out. So let's get started, guys. That video one that I told everyone to watch, I'm sure everyone watched it, but she definitely has a way that she prefers nuclear to be pronounced. So remember, it is nuclear, not nuclear. So nuclear energy, guys, nuclear energy can be used as a source of energy. The current source of energy that we use right now is where we break bonds of fossil fuels. So this is not the best for our environment, and it doesn't have the high efficiency that we hope we would. So that's why there's a lot of studies and a lot of new majors and looking into cleaner, more reliable types of energy. So that's what we look at. I'm not sure if any of y'all like drive to Port Mansfield or by Raymondville. There's fields and fields, guys, of those wind turbines. It makes me a little bit dizzy when I drive. But that's us looking for new, cleaner ways to have that energy that we need. So nuclear energy is definitely a controversial topic. Whenever people think of nuclear energy, I automatically think of nuclear bombs. They caused catastrophic devastation when they were dropped when they were dropped. So that's what people automatically think when they think nuclear energy. Dr. B does a good job of explaining the process and the science behind nuclear energy through this module. So in the 1960s is when the U.S. first got their nuclear power plants. We did stop by 1978. So what made us stop? It was us dropping the atomic bombs, right? So between that time that occurred, and it wasn't in the best practice to continue using nuclear as a source of energy because we had dropped nuclear bombs. So how do you feel about nuclear energy? I know when I first thought about it, I was like, I thought that was super unsafe. If you watch the Fukushima video, they had an earthquake and then they had a tsunami and then it caused a lot of issues. So it's just trying to see, do the benefits outweigh the cost of nuclear energy or the possible effects that can come from it? So right now, the energy that we're currently using has 33 to 42% efficiency. That is not a very high efficiency. We're not getting what we need from fossil fuels, and we're hurting our environment a lot along the way. So this is what a lot of people do at UT is they're trying to find ways to make a better choices and cleaner energy for us. So 20%, this was actually surprising to me, 20% of our electricity does still come from nuclear power plants. So in 31 states, 31 out of our states, we do have nuclear power plants. We have a total of 62 power plants throughout the United States and 100 active reactors. So 100 active reactors. Now we go into the second video where we talk about the nuclear reaction. So we will be using this formula a lot. You start to know it in your heart that uranium 92, that is its atomic number. So what happens if you have uranium, you blast it with a neutron, and the product is what is so interesting. Normally we think of law of conservation of mass, whatever. You start with, you end with. Nothing disappears. But reaction was completely different. So what happened in this reaction is you start off your beginning reactant, your reactant that you use is uranium, but then you produce barium and krypton. So in the production of this barium, krypton, and 3 neutrons, there is a lot of energy produced. So again, you hit uranium with a neutron and uranium is not a product. So this is why this reaction was like, whoa, what's going on? What is so different about a nuclear reaction? So currently, right now, chemical reactions have 500 kilojoules per mole of energy. So there's energy produced, but in a nuclear reaction, like the one you see above, 100 billion kilojoules. So it produces a vastly more amount of energy. So why aren't we using this, right? We'll learn throughout the series like what are the benefits and the risk of nuclear energy, but just know nuclear reactions have a large product of energy. So the difference is the mass, or the change in the mass from the reactants to the products. In a chemical reaction is zero, it balances out. But in a nuclear reaction, it is not zero. The mass of the reactants is larger than the mass of the products. This is called mass defect. So that phenomenon happening is why we're able to have so much energy produced from the mass defect. So the theory of relativity, energy equals mass times speed of light squared. On your exit ticket, I'm just asking you which one this means. So E is energy, M is mass, and then the speed of light is C. Speed of light is a constant, 3.0 times 10 to the 8. We learned about fission and fusion. This video particularly goes over fission. So in fission, you break a large atom or nucleus into smaller atoms, so it releases energy. So that is when fission occurs. What are the times that fission occurs? So it occurs with size. If you're larger than 26, so if you have more than 26 protons, iron and up, fission will occur. Before that, it is more than likely fusion. Next, we have your protons and neutrons ratios. So the ideal ratio of protons to neutrons is 1 to 1.15. And lastly, it is the energy of incident neutrons. Let's say that you're trying to have a fission reaction occur with something that is smaller than 26, like a 15 protons. If you hit it with a supercharged neutron, like a reaction is going to occur. So these are all the notes for today. They are uploaded. They're listed as LE50 notes, and this will help you answer the questions on the exit ticket. The graph, guys, is super easy. Just look at the legend. That's just making sure that you practice your graph skills and how to read data. And that's it, guys. Good luck.